Hello everyone, and welcome back. In this video we're going to go over negative exponents. So similar to before when we defined x to the 0, or we defined what 0 powers look like, we're also going to define what negative exponents look like. And we want it to be consistent with the quotient rule again. So let me write out some things. So last time, just to review, last time we said that if we have anything to the 0th power, so if we have x to the 0th power, anything but 0, we always get 1. So x does not equal 0, note that here. So anything to the 0th power is 1. That's what we settled on last time as our definition for the 0 exponent. But this time, what we want to do is we want to settle on a definition for what a negative exponent is. And the way we're going to do that is we're going to appeal to the quotient rule again and see how we want to define it. Well, this is actually the same way the book explains it, and I think it's really nice. So say we have something like, I'm going to use slightly different numbers in the book, but it's the same principle. So say we have 3 squared over 3 to the 5th. Let's think about what this is, and we're going to think about it without applying the quotient rule yet, just like before. So 3 squared, by definition, is 3 times 3, 2 3s, and 3 to the 5th is 3 times 3 times 3 times 3 times 3. There's 5 3's being multiplied. 1, 2, 3, 4, 5. Awesome. Now, just kind of using some algebra you may have learned earlier, we just canceled some things out here. Cancel all that stuff out, and what's left on the top is a 1, and then we've got 1 over. Now we think, how many 3's are there? There's 1, 2, 3 3's, right? 3 to the 3rd power. And now let's think about this a different way. So we've got this to start. And now let's think about this with the quotient rule. We're going to view the same exact problem, but instead with the quotient rule now. So with the quotient rule, we know that when you're dividing like powers, it corresponds to subtracting the exponents. So we have 3 squared over 3 to the 5th. That's the same thing as 3 to the 2 minus 5. 3 to the 2 minus 5, well, that's 3 to the negative 3, right? And so notice, we had the same thing here, same thing here. We got 2 different looking things, right? So that's actually why we define negative exponents the way we do. This, we'll say, is the same thing as this. And really what we mean is that anytime, like in general, what we mean is that anytime that we have something of the form a to the negative n, so something with a negative exponent, so, then we define it as 1 over a to the n. This perfectly corresponds with our example. This corresponds to that, and then this one corresponds to that. Awesome. So I'd like to end this video here with negative exponents, and then in the next video, what we'll do is we will go over some examples with negative exponents, and then we'll move on to simplifying some exponents using the power rule. So yeah, that's it for this one, and I hope you guys have an awesome day, and we'll see you in the next one.